Hi everyone, thanks for joining us today.
It does sound sophisticated.
Sophisticated, yeah.
With the ACE community for 3 years now.
Actually outlined everything.
Something that we find in the society.
First, talk about the problems that you're trying to solve.
Hi everyone, thanks for joining us today. We have another episode of Deep Random Talks with Carla, my co-host, and Niklas. So we're going to talk about decentralization for laboratories and how experiments in biology and similar areas happen, and how Niklas and co are imagining how it will happen in the future. So it's a very, very interesting conversation. You know, a lot of interesting tidbits about, how we are doing research and science today and how these ideas around decentralization can be used to take it to the next level. We are all have done a lot of interesting things in science, but definitely, where can we go to make it even better? So, Carla, what's new with you? What's happening in your life these days?
Yeah, hey, what's new with me? So I'm currently packing my bags. I'm leaving for Italy So this week, I'm going to go to Italy this week, going via Switzerland. I'm driving by train from Germany through Switzerland and then to Italy. So I'm very excited about that. And currently trying to fit my entire life into a gigantic suitcase, which is a challenge, but I think I'm getting there.
Very familiar with that. Been doing that for almost a year now. And it is, as I was telling you before recording, it's challenging on the weeks that you have to move, but otherwise it's a lot of fun. What are you drinking, Carla?
Yeah, so I got a cucumber water. I'm still at my parents' place. They still don't have any fancy drinks here, so I just made it myself.
Awesome. I'm having my peppermint tea that is iced. So, Niklas, how about yourself? Tell us a little about yourself. What are you drinking? What's happening in your life these days?
Yeah, maybe I should start with what I'm drinking. I'm drinking cherry tea. So I guess that falls into the bit more fancy category. At the office in Berlin right now, I'm a physician by training, also trained in computational biology. Worked for a short while in academia at the German Cancer Research Center and the Broad Institute. And then, started LabDAO, where we try to build a place for scientists to work completely online. And I'm calling you from Berlin, our office, where we have bottled tea.
In very Berlin. I was expecting you to have some mate or something.
I was actually right before the show going to the fridge, and I had to choose between tea and mate, and I thought mate is just too generic. So
too much of a stereotype.
Yeah, exactly.
Understand. But yeah, cool. All right. Very interesting. So what brought you into trying to decentralize science? What were you doing before LabDAO? You mentioned you had a short stint in academia. What was that experience like, and what were you working on?
Yeah, so I was always interested in inventing, especially therapeutics. I wanted to be in medicine. It was very clear that I was more interested in building tools for physicians and being one that's practicing myself. And then within academia, quickly realized that it was relatively hard to take an innovation outside of academia into the market. Was frustrated with the technology transfer process, and then also frustrated with some of the hierarchy that comes with academia. Being a medical student, I started working in the lab like 1920. Started having my own ideas relatively early, but it would have taken me very, very long until I could actually tinker on my own ideas. And there was one key experience that I had when I was in grad school in the US, when I received an AWS grant, where AWS, Amazon Web Services, they would just give me $10,000 in cloud credits. And I was like, that's like this moment where Dobby is given a sock, where I was like, I'm still a student. I actually why do I deserve this? And someone is giving me this amount of cloud credits, and I was already training in computational biology at that time. So I this was a lot of money. You can do a lot of compute with $10,000 in AWS cloud credit. So I felt like, wow, I'm a real scientist. I'm getting a grant and I can do science. And then, so I got together with friends and we worked together just on this grant. And that was a moment where it clicked for me that, wow, on the internet, everybody can be a scientist that has a good idea, and computation is lowering the cost of doing science to the point where you can get a lot of work done with relatively little funding.
Yeah, it's crazy what a little bit of money can do. How it can make you feel when you get that to actually do your work. It's like very validating. But so what were you using the grant for?
In short, it allowed me to work on an idea that my direct PI was not supporting, that I had sort of come up with during some of the classes that I took, and I wanted to explore, but it was clear it would require a bit of funding, but there was no support for it because it was considered to be a bit too out there. You coming together online, you having some funding that you can spend online on compute in this case, and then we pulled a public data set, we tried a very new idea, and then we wrote it up in a manuscript and we posted it on archive, and we applied for which at that time it was called an extended abstract submission at NeurIPS for the healthcare and biomedicine track, and we got accepted to NeurIPS as students that with our own grant money, and that experience, that was sort of what kicked it off, which was like, if you have a good idea, you can find money on the internet to like pursue your idea, especially if it's an idea that's involving existing data and computation.
The most important reason that I left academia was that the structure of how you can work was very predetermined. Like, you do very specific actions, like do your research, listen to your supervisor, do these activities, publish papers, get postdoc jobs, and then postdoc jobs, and then postdoc jobs, and many of those, 10 times probably, until you find a faculty position. And along the way, you go through all the typical steps of, publish again so that you can get funding to publish again, so that you can get funding to publish again. So, and the very first time, you've been from Europe, probably are familiar with Marie Curie grant application. The very first time that I wrote my very first serious grant application, I spent a month full time on this application. And when I submitted it, immediately I was sure that I wasn't going to get it, because I was working at University of Oxford in a lab that 5 other people were applying, and all of them were at least as good as I was. So extremely competitive environment. And the morning after submission, when I woke up, I was like, wait a minute, if this is the amount of labor I have to put in to get a small amount of money so that I can do what I want, why don't I do this for all the other ideas that I have? So I feel like where you're going with the story, and what the crucial point of, the turning point in your story, in that, inciting incident was that all of a sudden a whole new world of access was created for you. Like, prior to this, probably you were following the playbook of, this is the checklist of things you're supposed to do so that you can do these other things on the checklist, right? But all of a sudden you were like, wait a minute, is that the only way to do it? I left and went to industry and tried to find that there, and it wasn't there either. But, it's very interesting. Is that like the whole access that was opened up to you? Was that the moment that you realized you can do things differently?
Yes, I think so. It was the realization that with a relatively small amount of money, you could do research highly collaboratively, and that we were not, like, nobody is forced to do science according to the playbook of academia. It certainly is a well-trodden path. There are certain benefits that it comes with when embarking on it. But I think there are also certain drawbacks. Doing science in academia is not very collaborative. It's always a question of, who did you do it with? Were you the one that put in the most work, or are you the first or the last author? And that is not a very productive question to ask, especially in the early innings of a scientific career, where I felt like I was junior, and I already felt that pressure to be early, like to be very scientifically productive, and that process to be like a single player game, and then the observation that, oh, we could just be in this WhatsApp or Slack group chat and we could do an interesting project, and yes, there might be some kind of social structure emerging where it would be clear who would be last or first author, then that's fine. But it was more about like getting the work done rather than who did the work, and that was extremely refreshing, and then has changed my perspective ever since.
That sounds very inspiring. So this was the big realization, like science doesn't have to be that checklist. It can be a bit more free. It can be a bit more creative, more collaborative. So what did that realization spark? Like, how did you then get to starting LabDAO, and what was the initial idea? What were you trying to do?
So I finished medical school, and during those last innings of medical school, the pandemic happened. I read quite a bit about what makes up a productive scientific environment. There are some people that really inspired me. Ben Reinhardt wrote a really great article on private ARPAs, and there has been some other work by Adam Marblestone, Sam Rodriguez on effective research environments. And with these thoughts, I started also reading a lot about DAOs and these loose online communities. And then I stumbled over VitaDAO. So VitaDAO is a collective of enthusiasts and scientists that want to fund aging-related research. So VitaDAO's core business activity, you could say, is we're an online community. We look at different scientific projects that are currently happening all over the world, and then we identify scientists that are working on something that is A, hard to fund, and then B, has some potential translational value. And then we talk to the universities, and we sign a sponsored research agreement in which we basically purchase an exclusive license to whatever IP is generated in the scientific project that has been discussed with the scientist, and in return, the scientist is receiving funding. And that was what we did at VitaDAO. And then, however, over time, I realized, well, at VitaDAO, we're in the business of deploying money into these universities that I had come to understand as being somewhat outdated in the way that they operate, or at least most of the time. So then the idea became, okay, well, beyond giving money using these online communities, what else can we do? Can we actually build an online community where the science is happening? And for me, my personal experience was, yes, we can do that, right? You can do some interesting science completely online. And that was the beginning of LabDAO, where we said, okay, let's build an online community that's focused on infrastructure for scientists, where scientists can spend their time, they find someone to collaborate with and build a team, and they find tools that they can use to do the science so they can actually be generative. So that over time, you might end up in a future where you have scientists working online collaboratively, producing, in some cases, IP that they can then be purchased from these collector DAOs, such as VitaDAO.
Okay, so in essence, LabDAO is a place where scientists gather online, find other scientists to work with, and then do science together as well. And this is all happening on your Discord, or how can I imagine as a scientist coming into the community? How does it work?
Yeah, so we try to make the Discord a place where this can happen, where at least you find your group of scientists that you want to work with. And we actually invest quite a bit in continuously revamping the Discord and building also gated channels. So channels where a group that has already found itself and wants to work on a project says, okay, we're going to close the door here a bit behind us. If you still want to get involved, you can file an application, but we really want to get to work here, and we don't want to be hearing the chatter on the hallway the whole time. So we're trying to actively iterate on what is the user experience of scientists working online and how we can improve that. So that's one part of the equation. And the other part of the equation is scientists, when they do science, they need some funding, they need collaborators, and they need tools that they can work with. So we're also actively, bringing tools, onboarding tools, and we're focusing on computational biologists and biology EML right now. So this is really about bringing together data sets and hosting some of these foundational models that have been developed over the last couple of months so that they can be easily used by the community members.
So that's very interesting and something that we have been experimenting in our community for quite some time as well. We just to give you a bit of context, we have a community of more than 10,000 AI researchers and practitioners and founders who are doing their own things, but use our community as a platform to exchange ideas, find collaborators, find talent, etc., etc. And importantly, exchange knowledge. There is a very significant component of I'm trying to do this thing. How can I do it? And a lot of people answer, or I've recently done this thing. Here is how I went about solving this problem, etc. So one of the things that we have noticed in getting a bunch of people in a room to do a project together, especially whenever we experimented with the gated model of a bunch of people start something, and then if you want to join them later, you need to go through an application process. Obviously, I see the pros because that's a more exclusive group. You don't have to spend all of your time onboarding people, etc. But the downside of that model, or a big problem of community projects in general, is the retention. So people are not necessarily motivated to stick to a project beyond the first few exciting weeks or month. As soon as it gets to the hard point of grinding and figuring things out and really the difficult, nitty-gritty problem-solving part, a lot of people start to disperse. So what has worked in the models that you have tried? Because ultimately, for decentralized models, community-based models, ultimately a sustainable model of getting people to do projects together is going to be significantly important. Because if you can't solve that, all of the other, like incentivization, token-based economies, etc., are not going to work unless that fundamental self-sustained, self-organizing community comes together. So what are your observations for that problem, and how are you thinking about tackling that?
I definitely can empathize with the problem you're describing. How do you sustain activity across a group over a period of time? And I think there are some things that work relatively well. I think segmentation is a big one. So people, there's attachment. They do cluster. They do cluster based on shared past experiences, on all types of variables that might not have anything to do with the actual project that people are most excited about. And then I think it's important to some extent also respect that clustering. And then they also cluster around project ideas. And when they cluster around project ideas, I think that's the first step. You want to have that clustering exist for a sustained period of time before you start introducing any type of financial incentive or financial reward for being engaged, or any kind of governance token, because these things they do have the potential to obfuscate real intrinsic motivation, and going maybe into like some models from startup land, like it's basically there's no idea market fit. The idea and the team, they don't actually really match relatively well, and then you introduce external incentives that might lead to a very unstable team, that the moment that something doesn't go according to plan, or the moment that some of the incentives disappear, the team disintegrates. So I think it is important that you start out with this hot plasma, this hot dust ball of ideas and people. They start to aggregate, and eventually start to create a different velocity by letting them segment. And then step 3, you give it some time before you start introducing additional resources and governance mechanisms.
Mm-hmm. So I definitely see what you're talking about, which is great for creating the initial grouping and momentum. Like I definitely have seen that happening in our community as well, where people gathered around ideas and given, what they thought they wanted initially, they either lasted or not. That segmentation makes a lot of sense. I think, I don't know if you have observed this as well or not, but the ultimate objective is also a very, very important parameter. Like sometimes a lot of people gather who are in the same state of the mind currently. They have similar expertise, therefore their pace can be similar, but they might not be looking for the same ultimate goal, right? So I think there are 3 important parameters in there, like the current state of your mind and or expertise, which determines your current position and speed, but also where are you going? Like, are we traveling to this destination or a different destination?
So how do you, as the core team, so you're saying there's teams of scientists that are doing research, starting to talk about research projects, and then some of them be like, okay, I want to just research this, put it out there, I don't want any IP. Then they'll just go through some public goods funding or something. And the other group of researchers is more interested in actually creating IP or creating technologies or any sort of mechanisms which can then be monetized, is what you're saying. So is there in your community like a initial, like at what point does a community or a research project need to say, hey, okay, LabDAO, I want your support on going the IP route, or no, I want to do a public goods thing? Or is it a very fluid process? Because once you, as LabDAO, as the core team, start pouring resources into the project, you probably also want that to follow through, right? So at what point do I need to commit?
I mean, we are actively working on a structure for this. So this is a really good question, to ask, and I have a proposed answer, but it would be too early to say this is what we've experienced to work. But I think what we're probably going towards is like a semester model where you might even have these sort of semesters where projects launch in a given semester and there's an overview and you can decide whether to join or not. And then every team has a set amount of milestones, and once they reach a particular milestone, they then demonstrate where they're going, and then depending on where they're going, there's a decision by either the core team or eventually a mechanism that we still have to determine on whether they receive some internal resources to then go one step further. And then after that, it really is a question of, is there anybody else in the ecosystem that wants to further support that work? Because our resources are limited and we're just in the business of spawning scientific collaboration. We're not in the business of long-term funding it or sustaining it. That's something that other science funding agencies or Vita DAO or other funding DAOs are better equipped to do.
One of the other things that we noticed in our community was, we started on a Slack, you're using Discord, but very quickly we realized that there had to be some sort of a platform that captures all of these interactions and conversations, all of the knowledge sharing, all of the project people are building. So let's talk a little about the technology side of what you're building as well, because I assume you're building a product as well, potentially blockchain based, etc. So walk us through what is happening there, because we talked extensively about Discord and the processes that you're using to do community engagement, but then what? Like, what's happened? Like, what is the platform you're building?
The most fundamental tools that scientists need when they're a computational biologist is access to compute, and ideally not bare metal AWS access to compute, but ideally something that's already pre-wrapped, where you have a set of different pipelines that you can choose from to run an analysis, or like a Hugging Face-like experience where machine learning models are already served for you. the goal that we have with the lab exchange is that we can start with that. We can start with hosted machine learning models. We can start with hosted bioinformatics compute, and then grow from there into physical laboratory services over time as that becomes also more relevant for the community. Which actually is one thing that we learned the hard way. It's not about onboarding physical lab service right from the start. Actually, when you think about what is the most organic way to do research online, the most organic way to do research online is to use your laptop to analyze data that's already there, or to work with a machine learning model that has recently been developed and figure out something new. And that's what we're focusing on. So it's all about serving these applications in a peer-to-peer system where some members in the community, they can host APIs, they can host compute according to a schema that we're defining, and then other folks in the community can use a command line interface to consume these services.
No, very interesting. So the idea is, as I understood, and correct me if I'm wrong, basically you're providing Hugging Face for bioinformatics, might build out future other services, but that's the first product that you're actually offering. How are you planning to monetize that? Is that a subscription model? And then also the way I met you was in the decentralized science community, which is very crypto focused. So I'm interested, where's the crypto bit and why?
Yeah, where is he hiding the crypto? Where? So the client that you're using to run laboratory services on someone else's compute needs to keep track of what is the service that you're requesting, and then what is the result of that computation that is coming back, who actually ran it for you, and then that person that ran it for you, they want to have some sort of reward. They are incurring perhaps a compute cost. So you need open source payment systems if you want to have a completely open source experience, and that's where crypto does come in. So the idea is that you download the client, you have an overview of different applications that have been maintained by the community, and then you can run an application. And then when you run an application on someone else's compute, you pay for that through basically the XDAI network. And then when you get your result back, it's yours. There's even an on-chain receipt that you have. Some people call that receipt an NFT. And then, basically that's the central primitive. What we are really excited about is to run it a bit like a co-op or a public benefits company, so that actually the fees that are generated from some of the fees that are generated on the exchange actually also flow back to the group of maintainers that are maintaining that particular application. So you don't only pay for the compute, but you also pay for the person that has been putting in the work and maintaining that tool. And that's actually something that I think is a bit broken about some of the business models that you currently see in machine learning inference, where, especially actually when it comes to academic model inference, where you have scientists that have really been putting in the work of developing these models, of maintaining them over time, and they release them open source, and then they become extremely useful, and there are companies that build great products with them, where the core offering that the company has is literally just serving the model in an effective API. And the approach that we take is, well, there can be an open source version of the serving of the model too. You just need to have open source payment systems. And that's been the missing piece for the open source community, where you as an open source contributor, it was very hard for you to monetize your work, because it was hard to set up a PayPal and Stripe. That was not very in the spirit of open source. Now with these tokenized ecosystems, the maintainer of the algorithm can actually earn something for the work that they're doing. At least that's what we're trying to get towards, and thereby build a sustainable science ecosystem where, if I'm a computational biologist, I can do my work, I can open source something, but there are additional sources of revenue beyond grant funding. I can actually earn something for maintaining a tool that's useful.
There is some sort of a marketplace. There is some service that is provided. It is either a hosted model or eventually lab equipment, etc., etc. That's the supply side, and then there's a demand side, other scientists, or maybe at some point, industrial researchers who are interested in probing these models to get some results. They have some data from their lab or whatever else, and they want to do a particular type of analysis. So that's the demand side. So these two sides interact with each other through some protocol that you have, and then some money, quote unquote, some currency is exchanged. In your case, token based, probably crypto based exchange of currency that happens. And so part of this currency that the demand side is providing will go to the provider. So you ran my model, so I get part of this money to sustain my cloud services or whatever the operations that I have, and part of it is my reward because I provided this, and part of it will go to some central treasury of sorts that support other players in the ecosystem, like those who are maintaining models or even the operations of your venture, probably. So one thing that I always have a hard time wrapping my head around, and I'm curious about how you're dealing with this, is that normally if you don't anchor a token-based economy to some sort of an external utility, then the generation of tokens become kind of arbitrary, like you're just randomly generating tokens rather than generating tokens when there is an injection of cash, like dollar values, into the ecosystem. And sometimes also tokens are cashed when there is not an injection, but the opposite, like some values is leaving the ecosystem, therefore some cash is injected into it, etc. So what is the anchor mechanism? What is the utility mechanism that keeps this overall ecosystem stable rather than it being, fluctuating and completely volatile?
Yeah, absolutely. That's an important question. So if I want to run expensive compute load, or if I want to run a laboratory service, you want to use a stable currency to do that, because the recipient of that currency will have to sell it in order to pay for the electricity bill or pay for the laboratory technician, the rent. So it doesn't make sense to invent any new currency for that. In fact, it was a really, really, really bad idea to try to do that for various reasons, including regulatory reasons. So that's not what we're about. What we're about is to create you could call it a co-op structure, where it's overall a nonprofit endeavor, but you earn membership, you earn ownership of this overall community by providing useful services. So there's an incentive for you to provide the infrastructure to the community. And then when you provide the infrastructure to the community, the thesis is that scientists will come together in the community, they will do interesting work, and then some of that interesting work might be commercializable, and then this nonprofit umbrella organization can come in and support some of that work and mature it further. So we are sort of moving between the sort of nonprofit mission of supporting science, but then also or work towards having the ability to then also support the most interesting science by getting it into the room with funders who want to mature those projects further, but also be able to, just like a university, support these teams and in return get some exposure to the upside. Right now, that's what's happening in university tech transfer, and we believe it's relatively easy to beat that user experience.
Okay, so I'm interested in the bit where you, as a nonprofit umbrella organization, then start supporting decentralized research communities to then actually get further funding, because I guess that's the hard part, and that's why this whole thing started, right? So the idea was that getting traditional funding is very hard. So let's do the LabDAO version of it, and everybody works together in a collaborative, decentralized way. But then when you need actual funding, or like a lot of funding, then you still need to go back to the traditional model, I presume. Or is there other funders that you can connect these people to? And then how do you facilitate that transition back into the traditional or non-traditional environment?
when you have a small project idea that you literally just want to test whether it has some merit, and you're lucky enough to be in the realm of computational biology or machine learning research in general, $10,000 of cloud credit and maybe a stipend for $1,000 in consumables, so you can, make up some time in your week to keep working on this for at least a couple of weeks. That can already get you to a point where one could expect you're able to present some level of traction over time. And that is basically the core. The core idea is there is something within the sort of $10,000 range that where you can enable a team or an individual scientist to try to work on a hypothesis and refine it further. But then when you get into the $100,000 range, that is an amount of money that you usually would get in a small grant or a sponsored research agreement, or that's even something that a Gitcoin cannot even support you with. Like, a good Gitcoin grant is one that gets $10,000 to $20,000. It's very rarely do you have a Gitcoin grant that gets six figures. So the moment that you hit the sort of six-figure landmark, you're in the sort of traditional scientific arena where that sort of six figures, 200K, 300K, that's usually what a sponsored research agreement is valued at. If, for example, a company wants to pay a university lab to do an experiment and purchase some of the IP, sponsor some of the IP, that's usually it's like a six-figure project. And then these big grants, ERC and larger NIH grants, they can be $1 million grants, but usually you're in the sort of six-figure range. And right now there are some funding DAOs that have the firepower to do six-figure grants. So DAO is one popular example, and I'm obviously biased here. But they look for very translational science, right? They look for science that can actually generate potential therapeutics related to chronic diseases. Now, a lot of other projects, so we can help match make that. If there's a team that's working in that regard, we can put them in touch with folks at DAO. And I wear two hats. I also am still a core at DAO, so there's definitely a conflict of interest here. Something else, however, that we are currently working on is to also find a way to have those teams, when they assemble, wrap themselves in a legal wrapper that's allowing them to ideally be able to ask for funding also in this traditional ecosystem that we currently have. And we will have for quite some time. Just to create some perspective, the NIH, I think, is managing about $40 billion of capital annually that it's deploying in scientific research. This is going to take some time, and it's not unrealistic to imagine that it might never happen that crypto communities could deploy that level of funding into scientific research. So we need to create a way for these communities to be able to raise funding in the traditional ecosystem, and that's what we're actively working on right now. So like, you're going to meet online and you're going to be working online as long as you can, and then however, at some point you basically need to off ramp from Web3 into the real world and get your funding there. And we need to make sure that there is this sort of off ramp for you when you need it.
Niklas, looks like you have some very interesting project going on. A bunch of people have gathered around you. Let's talk a little about your traction. What's the size of the community? How many projects are happening? Just give us a sense of, what are the skills that you're talking about?
We're still very early, very, very early. We have about 1,500 members in the Discord. It's growing. We have 7 projects, I think, that are currently active. Some of them you can currently fund in the Gitcoin round. So one project that I'm just highlighting from that collection is collaboration, for example, with Gainforest. Gainforest is a rainforest conservation project that uses satellite imagery and also mobile end device data that is being collected to measure the maintenance of rainforests. The team is using machine learning models around computer vision to analyze satellite data and measure the circumference estimate the circumference of trees that are being captured with the mobile device, and using those data to reconstruct the health of a given plot of rainforest. That's something that I'm extremely excited about. I'm a physician by training, so it's nothing that's in my wheelhouse in terms of expertise. But I think it's a perfect fit for Gitcoin, and the team has been already at this for quite some time. David is a good friend of mine. He's been working on this for a while, and they're actually right now competing in the semifinal of the X Prize. So now I'm just shilling this project a bit, but if you're interested to Gitcoin, you can support it. And then if you really like the science, join the science. You can actually compete in the current X Prize for the rainforest monitoring category. So I think that's pretty exciting.
Yeah, very cool, very impressive. Just for everybody who doesn't know what Gitcoin is, it's basically, and I may be explaining this wrong, Niklas, you can correct me, but Gitcoin is basically a platform. It's a public goods focused funding mechanism. I think it's based on Ethereum, and it's all about giving out grants to different projects and organizations that are doing public goods work. And you can go in and fund projects, or you can apply yourself and get a grant. Because currently, apparently, there's a lot of people in Web3 who are trying to give out money to things where they think they can cause some good in the world. But yeah, super cool. Love to hear that your projects are already at that stage and receiving some funding. So it seems like it's going pretty well. Like you're saying you're early, you're still building. What's the current challenge? Like, what are you currently working on, and what is there something that's kind of just really annoying the heck out of you, or like what's the big problem that you're working on right now?
A really big problem we're trying to solve for right now is how do we scale this organization gracefully? How do you go from there are 3 teams to 30 teams? Because there is this one point where, like right now, you basically I can be on a lot of these calls, and I can like manually, keep the ball up in the air and engage with these groups. But going from 7 projects to 70 projects, that's going to be quite a lift. So you need to find a structure to reduce the cost of launching a team and doing your work. That means great documentation. That means actually building products that lower the activation energy to engage within your community. But also you need to find ways to scale at least like parts of the core team, because facilitators will be needed. I think no matter where you are, and universities currently offer this sort of facilitation in one bundled service, and I guess we're sort of unbundling it to the point where a team might bring in a grant from the NIH potentially, because we've been able to legally wrap some of these communities, but then they might still want to get some facilitation from the core team, or like a group of facilitators, and that's something that we're trying to build out as well, so that these teams can do their most effective work.
We recently were talking to Renee from LabDAO, I believe, and she was telling us about these ideas around progressive decentralization, which I think is what you are touching on, essentially the fact that largely a central group, I guess maybe not even you would call yourself a founding team, but the first core team running a lot of things, being very hands-on in everything, and progressively getting to a point where you're financially sustainable, operationally sustainable, and eventually to a self-organizing ecosystem is definitely a very, very interesting challenge to tackle. I'm very excited to see where you take this, Niklas. I really love this idea of, reimagining how universities work. Ultimately, science is the best story we have told ourselves about the universe that we're in. And doing it better is definitely going to be good for everybody. So let's wrap up. You're running out of time, but what's the verdict? What's the takeaway message that you want? What's your call to action for those who watch this episode? What do you want them to do to think differently going forward?
If you are a machine learning researcher, and it seems like, Amir, there are quite some machine learning researchers in your community or people that are interested in this overall field, and you want to work on a biological problem, but maybe you've been missing someone who told you about a pressing need or access to infrastructure to actually test whether your protein that you predicted folds, then we would love to work with you because this is literally what we're trying to build.
Honestly, what I'm taking away mostly from the episode is just how much better science can be and how much momentum you can create by just giving young scientists a little bit of money and letting them, realize their dreams. I think we should do that a lot more.
So hope you enjoyed watching this episode and it inspired you to think differently about how you do your work, either science or not. And take a step outside of your comfort zone and build something interesting. Thank you so much for watching this episode. Thanks again, Carla and Niklas, for joining me today. And hope to see you for the next episode next week.